Hello everybody, I hope you're having a fantastic day and I hope that you are ready to learn. We are going to learn KiCad today in one video, and we're going to start from designing a schematic to choosing the footprints to putting those footprints on a PCB to exporting the PCB to Gerber files, generating a 3D view of it, sending it up to PCBWay to get it manufactured, and setting up a shared project so that you can get commission off the PCB that you designed. How awesome is that? So let's talk about what we're going to build. The WeMOS D1 Mini is a little microcontroller that has Wi-Fi and some pins and stuff like that. And the idea of it is that you can stack these other shields on top of it as tall as you want to add additional functionality. So the problem comes in if you want to do something like this RGB LED. You can't really stack the relay on top of it because it will block the LED. And if you try to stack it the other way, it won't fit. And so the idea is that we're going to take this WeMOS and we're still going to be able to stack stuff on top of it, but we're also going to be able to stack stuff here and here and here, which means that we can take our WeMOS and add an LED and a relay and even another custom PCB that I made on KiCad. And then to add a little bit more functionality, we're going to add some extra pin headers for prototyping and some pin headers next to these so that we can have more things plugged into this board itself. We're going to add some of these cool screw terminals so that we can do prototyping without having to make those special DuPont wires. And we'll be able to basically do anything we want with the WeMOS D1 Mini. In fact, if we want to, we can even add a proto shield to our proto shield, which is just wild. But of course we need to thank the sponsor of this video, PCBWay, because thanks to them I designed this and this and this and this and this and all kinds of other things that make my life better. And so I am excited to partner with PCBWay on this video. Although you will be able to take the files that we design here and take them to any PCB manufacturer of your choice, PCBWay is truly my choice. They're the ones that I use for my commercial projects. They're the ones I use for my personal projects. And it's because I love them. They make great boards quickly at a great price. So we're going to talk about them throughout the video. Go ahead, download KiCad version 8, and let's get started. All right, so once you have KiCad installed, the first thing you're going to do is make a new project. So we're going to go to File and New. And then in my case, I'm going to put it in my another maker folder just so that you guys can have this when we're done. I'm going to right click, new folder, and it's going to hang up a little bit probably here, but so we're just going to call this KiCad 8. All right. And then once we create the folder, I'm going to double click it, and then I'm going to call the project KiCad 8. So now you have a new project, and the first thing we're going to do is we're going to make a schematic. So essentially, just to kind of walk you through the process, we're going to make a schematic that's going to show us electrically how the project is connected. We're not worried about where parts are or anything like that. And then the second thing we're going to do is we're going to identify the parts with what we call footprints. Then once we're done with the schematic, we're going to take everything and put it over onto the actual circuit board. And then we're going to decide exactly how we want the board laid out. Now, since the goal of this video is to get you up and running quickly, I'm not going to spend a lot of time trying to make things super neat here. If you are doing this for yourself and it's a hobby, I encourage you to take your time and enjoy the process. Now, the first thing we're going to do is we are going to go over here to add a symbol, and a symbol is kind of a good word for a part. As you can see here, I've already filtered where I found out that there is a WeMOS D1 Mini on here, and just to show you, if there wasn't a WeMOS footprint, then honestly what you could do is just count the number of pins here and just use pin headers. We're going to be using pin headers in a minute, so I'll come back to that. But in this case, we're going to want a WeMOS D1 Mini, and we want to show that one of those is going on the board. Now, if you'll notice, this looks nothing like a WeMOS D1 Mini. It is just a representation of the board, but we're not actually seeing, you know, the outline of it. And we're actually going to want to show 4 of those because we're going to have a, you know, all of our breakout stuff. So we're going to put 4 of them here. As you can see, I'm not worried about being too neat. We're going to talk a little bit about moving around the interface. I'm using a mouse with a mouse wheel, and I recommend that you do the same. So as I scroll the mouse wheel in and out, you can see that I'm zooming in and out. If I click the right mouse button, I'm moving the entire unit around. And yeah, those are the main things you need to know. So we're going to center on that now. And I'm going to right click to drag this thing up a little bit. And I think what I'm going to do is spread these out a little bit. So I'm just going to highlight the whole thing and drag and move. Let's get them down because we're going to want some space on top and bottom here. So I'm going to drag these down here. We're not going to worry about being too neat, but we'll get these around here, highlight the whole thing, move it down, and there we go. So the goal of this project is not to just put 4 WeMOS D1 minis on one board. We want to add some pin headers to the left and the right so that we can tap into them. We want to add some places for power and ground so that we can tap into that. We want to add some screw terminals for easy prototyping, maybe an LED and a push button. Yeah, we got things that we want to do. So in order to do that, we need to add symbols. Now, the first thing we're going to start off with is a bunch of pin headers that we can interact with. Those are pretty easy. So what we're going to do is we're going to come over here to the symbol thing, and all of the headers are under con. They're all connectors. But usually what I do is I think about, do I want 1 row or 2 rows? And then how many pins do I want? So if I want a 40 pin connector, which I don't, then I would do 2x40. And that's going to give us a 2 row by 40 connector. You can see I use my mouse wheel to scroll in and out. But in our case, since each side of the WeMOS has 8 pins in it, then we want a 1 by 08, not just 1 by 8. We want 1 by 08 connector. And so we're going to go ahead and grab that, and we're going to put that in here. And then we're going to want a couple of those. So let's say we'll keep it simple. We're going to do 1 for each side of the WeMOS, and then we're going to do 1 for each of the screw terminals. So what I'm going to do is I'm going to copy this and I'm going to paste it. Before we go any further, if you look at the WeMOS, the pins aren't in order when you're looking at the actual board. And so what I want to do is I don't want to mix up the left and right side. So I'm always going to look at it that when the USB is down, that's going to tell me left and right. So we'll show you that when we get to the board. But what I'm going to do is I'm going to just call this, I'm going to put an L there so that I know that that's the left side, and I'm going to put an R here so that I know that's the right side. All I did was double click this when I had the pointer selected, and I was able to put some some designations in there. So we're going to copy this, and I'm going to do 1 more for the screw headers, and I didn't want to forget which one was left and right. So, and now that I've done that, I can actually come over here and take this one and put it over there with the other right one. And I can take this one and put it over here with the other left one. Now, again, this will make more sense as we're doing it, but we're going to go ahead and add some more headers for 5 volt, 3.3 volts, and ground. So let's do this. Let's come in here, and let's say we want 5 pin headers. So we're going to do 1 by 05. And then we're going to get this in here, and we're going to put, let's put these up top since most of this stuff is up top. So I'm going to do 3 of those. And now we're going to do the same thing here so we don't forget what it is. You're going to make sure you switch back to your pointer. You're going to double click this, and I'm just going to put a .g there. And I'm going to put a 3.3 here. I'll just put a V. And I'll put a... Now there are other ways to label this stuff, and other people may like their way better, but I do this and I tend to not mix things up when I do it this way, so this is how I do it. So although we have some more components to add, I think it'd be good if we started connecting things together so that you can see a little bit about what we're doing. The first thing I notice is that on the WeMOS over here, we have the 5 volt is on the left and the 3 volt is on the right, and I did it the opposite way on my headers, and there's no reason you can't do it that way, but I'm going to move this around so that it's just a little bit less messy on the wires. And so we're going to do some wiring. Now, if you notice, if I click on just this, it's just going to move the label. So a lot of times you'll see me draw a complete outline around it. If you click the right spot, it'll select the whole thing. But if you have space, drawing the whole outline is great. So what we want to do is we want to start making the electrical connections. And as you can see over here, I'm hovering on add a wire. So what I want to do, it tells me here that this is the 3v3 connection. So I want to make a set of connected headers where no matter what pin you plug into, you're getting 3v3. So what I'm going to do is I'm going to click and draw, and then over here I'm going to go to pin 5, and this connected electrically the 3v3 line on the header to this one. Now these aren't connected by default, so I need to come down here and just draw a line and connect them all together. And you can see that wherever two things bridge, you get one of these green dots, which can be really helpful because sometimes you may not mean to connect them. So we can do the opposite here. We can come straight down here through the 5 volts, and then we can click on this and come down here. And as you can see, it's kind of smart about the way it does things. Now, if you were really being anal, you would want these lines to have the angle at the same spot. I'm trying to get this done quickly for you, so I'm not going to worry too much about that. Now, the ground, we want to do the same thing. We want to come over here, click it, and then come up to the ground, and then we want to connect all of these ground pins together. And so that has given us breakouts for this stuff, which is super simple. Like, it's not that complicated, which is why we're learning this quickly. So I brought up a photo from the most excellent random nerd tutorials, and we're going to use that kind of as our guide. As you can see here, we've got pins that are in nowhere near the same order as they are in the diagram that you have up top. And so what we want to do is we want to make sure that when we put a set of pin headers parallel to this, that the wiring is in the same place. So the first thing I'm going to do is I'm going to make a couple of notes on those pin headers. So I'm going to come over here and I'm going to select text. I'm not going to get too complicated, but I'm just going to come in here and just put like 2-letter designations for each of these things, and I'll type these out and I'll show you what I'm talking about. So once I've actually typed out the labels, if I'm on the pointer over here, I can double click them again, edit them if I need to. You can see I chose 38-point font and all that good stuff. So what I'm going to do is I'm going to take this, I'm going to click on one, and I'm going to hit R, and that's going to allow me to rotate this. So I'm going to take the left one and put it over here, and then I've got a second left header, so I'm going to Control C, Control V that, and then I'm going to do the same thing on the right header, and Control C, Control V, and there we go. So now what we need to do is connect this stuff all up to the WeMOS. So this is going to get messy, and I'm not even going to try to be neat in a quick tutorial, but like I said, if you want to take the time to be neat, you probably should. First thing we want to do is make sure that these headers are parallel to each other, so we're just going to connect them together like so. And continue that the whole way through. So here's a top tip for you. Although there's a setting down here called the grid, I highly encourage you not to mess with that so much. I think you can go down to 25 mils, but basically by keeping everything on the big existing grid, everything will snap together a little bit better and these things will all connect. So that's just a pro tip. Don't mess with that until you're ready to get into expert mode. But the next thing, now these pin headers are only connected to each other. So the left is connected to the left, the right is connected to the right, but nothing is actually connected to the WeMOS. And so it's time to do that. So what we're going to do is we are going to go up to the WeMOS here, and we're going to find the TX pin. And this is where you can spend all sorts of time trying to be neat and all that kind of stuff. But basically you're going to come around here and make your wire connections, and you'll see that you get the dot there when you've made the successful connection. And the way it works in this world is that things just don't line up the way you want them to, so there's going to be a bunch of crossover and stuff like that. But essentially what we need to do is to connect each of these pins to its partner down here. So we're going to do that. It's going to take a little while. Just go through and connect everything to everything. Now I think I'm going to jump back in here and show you that when I made this last connection, I came up too close here and I accidentally connected to the 2 pin. So I don't want to do that. So to get rid of one of these things, all you have to do is click on the pointer and click on the wire. We're going to delete that, and then we're going to delete the connection between the two. So I need to get on that little tiny wire right there. Alright, as you can see, these cross over, but because they don't have a dot, they're not electrically connected. So we're going to come over here one more time, last wire on this side, and we're going to come up, come out here, and then I'll zoom back out. Okay, so I'm going to want to double check that, but essentially every pin on the first WeMOS is connected to these headers down here. So that's job done. So as you can see, we have a pretty full section over here, and what I think I'm going to do is I'm going to try to spread this out a little bit. So we're going to come over here to File and page settings. And to be honest, it's not like that we're ever going to print this out, so we can make this as big as we want. So I'm going to make it an A0 and give myself plenty of space to mess with. Now, if you watched while I was routing those wires, it did look like still the bulk of the right side connectors went on the right side, and then most of the ones on the left were on the left. So what I think I'm going to do is I'm actually going to move these down and put these on top of each other like this. And I'll show you what we're going to do. So I'm going to use my scroll wheel to zoom in, and I think what we're going to do is we're just going to go ahead and connect all the other ones together down here. So the 2 will get connected to the 2. So we're just going to go ahead and basically do this, and I'm going to leave myself some space for some angles, but we're going to come in here and do like that, and then we're going to click this one here, and we're going to try to make that mate up with the other wire like this. And these things are all just paralleled together. It's just a bunch of shields. So we're going to click that, and so we're going to go through the whole thing and essentially jumper the 2 to the 2, the 3 to the 3, the 4 to the 4, that kind of thing. All right, so that is that half done. Now we're going to go around and do the top. So if I zoom out on our schematic, you'll see that basically what we have here is we have these 3 shields are all connected to each other. This is connected to the pin headers, but these are not connected to this. And so what we want to do now is we want to make the connections between the 3 headers and their respective pins on the shields over here. So I'm going to go ahead and connect 2, 3, and 4 to 1. And I've been debating about how to do that. I think I'm just going to go straight from the WeMOS. So I'm going to come down here and then connect like that. So that's going to be a whole bunch of other connections just straight through, and I'm going to do that quickly. All right, so it's not the neatest thing I've ever built, but it is all connected as far as I can tell. We're going to check that in just a moment. I do feel like I would be remiss if we didn't add a couple of just passive components to this thing so that you could get an idea of how that works. So I think the first thing we're going to do is we're going to build in an LED so that we can tell if the power is on, and then I think the other thing we should do is add a reset button. There's a reset button on the actual WeMOS, but let's go ahead and put an external reset button. So what we're going to do is we're going to come in here to the symbol editor, and we are going to look for LED, and we're just going to add a simple LED to it. And we'll just stick that out here to the side. Doesn't really matter. Let's do, maybe we can do it up here. Let's do it up here. Let's see, we got 5 volt. Yeah, let's add that up here. And then let's go ahead and add a current limiting resistor for that LED. So we're going to just start typing in resistor, and we're going to add a resistor. And then we know that's going to have to go right here. So I'm just going to hit R to rotate it, and we're going to stick it there. And then the next thing we're going to do is we're going to add a button. And so I don't remember what the symbol is for that. So I think it's just push button. SW push. I think that's going to be it. So we're just going to add this standard push button, and we'll stick that. Where's the reset pin? We'll stick that right here. So what we're going to do is we're going to send power from 5 volts through the current limiting resistor, out the LED, and to ground. So what I'm going to do is I'm actually just going to stick this right here. So I'm going to drag this over, and we're going to make sure it connects, but yep, there we go. And so then since we're here, we can go ahead and take this and just grab that, and then anytime there's power to this thing, that LED is going to light up. Now the next thing we want to do is the way the WeMOS works is if you push a button between reset and ground, then it will reboot the board. So what we're going to do, just for clarity, we're going to come out here and we're going to come down to the reset pin, and then we're going to come up here and go to ground, which is actually right here. So I'll just click on that, and then that is our push button. So that completes the stuff that we're adding to the board, but it doesn't exactly tell us what we're adding to the board. In other words, we don't know if this is a 3mm LED, a 5mm LED, if it's one of those giant 100-watt LEDs. We have no idea. And the way that we fix all that is we run the footprint assignment tool. And what you have here, this can get a little bit messy, but what you have here is this is the designation that we have on the board. So when you look at the, so this is U1 WeMOS D1 Mini. So basically what you're doing is we're assigning these 4 are WeMOS D1 Minis. Now it's really a WeMOS and then 3 shields, but that's fine. So at this point, everything is laid out, but we haven't actually told the schematic what is in these places. Like, in other words, we know there's an LED here, but we don't know what size the LED is. We know there's a resistor, but we don't know the size of the resistor, all that kind of stuff. So what we're going to do is we're going to come up here and we're going to run the footprint assignment tool. So in order to read this, on the left side you have the component designation. So like U1 is a microcontroller here. So we have U1, U2, U3. All those are here. The LED would be D1, stuff like that. So we have those designations, but most of these, the right side isn't filled out, which means that we haven't told it actually what kind of that component is here. So if we click on the LED because it's first, we're going to go over here and we're going to find the LED library. And we want to do through hole, not SMD. These are surface mount, so we're going to go to through hole. And then over here on the right, you can see the various sizes of LEDs. So we have 5mm LEDs. We're going to use the smaller 3mm LED. So I'm going to double click that and you'll see that that gets assigned over here on the right. Now these connectors work just like they did when we were doing this side. For this thing we want a pin header, so we're going to go to connector pin header 2.54mm, which is the standard size, and then we want a 1x8. So we want to find 1x8, and you'll see that they are listed as horizontal, vertical, or vertical SMD. So we want vertical because we want the pin headers that stand straight up. So because we need a couple of these, we can copy this and paste this here, and that will get us connectors 1 and 2. Now for 3 and 4, those are the chunky screw terminals. So that would be a connector, what would they call that? That's a connector, I think it's RND. It is terminal block RND, and the ones I have are 5mm apart. So we want to grab the RND 1x5, 5mm horizontal. And so we're going to click on this and then 1x8, 5mm horizontal, and we have a second one of those, so we're going to copy and paste. Next we have 3 of these 1x5 standard pin headers, so we're going to come back here to 2.54mm and we're going to find the 1.5 vertical. So we're going to select that 1.5 vertical. There we go. Now we're going to copy this because we have 3 of those. Now for the resistor, we're going to use a standard resistor. These are a little weird to put in there. You kind of have to know the size, but we're going to use a through hole resistor, and you can choose to mount it horizontally, which is like laying on the board, or vertically. We're going to mount it horizontally, and what we want to find is when you look at them, a lot of these are vertical, so we don't want the absolute smallest one for the tiny resistor, but we're going to go up just a little bit bigger to give us some extra room. So we're going to take this one looks good, and we'll get a chance to see it on the board in just a moment. Just trust me on that size there. The last one we need is one of these buttons, and so we're going to find the button library, and this is through hole as well. And we can clear out that search term there, and we want tactile buttons. So we want the standard 6mm, which you may not know that's the standard, but that is the standard for 6mm tactile push buttons. So when we're done, we can hit save. Now there's this whole concept of nets, and we're not going to really spend a lot of time talking about that in this video. They can be super helpful for doing all your wiring and things like that. But we are going to add one symbol to the board that's a little different. So we're going to come over here to the power symbol, and we are going to add just a ground symbol right here to this ground connector right here to let us know, to let KiCad know where the ground is going. We'll see that in a little bit, but just trust me on that one. The other thing I wanted to show you while we're in here is in the event that you have a pin on something that you don't want connected to anything, you need to come in here with this little symbol here and mark that pin as not connected, and that will tell KiCad that you've done that intentionally. We're not going to do that here, but I just wanted to let you know because you could run into some errors if you didn't know about that. So we're going to go ahead and connect this back, and there we go. The next thing we're going to do, KiCad is probably going to throw a bunch of fits on it. I haven't tried it yet, but we're going to run the electrical rules checker. And the main reason why we want to run this is to make sure that nothing is disconnected. It's really easy to get in there and miss a connection or something like that. Now the fact is, it's most likely going to think that we have 4 WeMosses and that we're sending power to power and ground to ground, doing all kinds of weird stuff like that. So we're going to be ignoring some errors that we see, but we're going to still run the electrical rules checker and make sure that it doesn't say that nothing is disconnected or there's something else weird going on. So let's click that and run this. And you can see we get 14 errors. I'm guessing, yeah, see it's saying input power pin not driven by any output power pins. It doesn't know what I'm doing with this board, so I'm not going to spend a lot of time worrying about that. But what I am looking for is there anything disconnected? And there isn't. There aren't any errors about anything that is disconnected on the board, so I'm going to close this and we're going to move on. All right, so we are finally getting to the exciting part. We're about to make a PCB, so we're going to save our work. And we're going to go here just to make sure that all of our letters and everything are right. We're going to come down here and hit Tools and Annotate Schematic. There probably won't be anything to do there, but we're just going to let it do that. And then finally, we're going to go to Tools and switch to PCB Editor. And now we have a screen that looks somewhat familiar with similar tools, but different because this is for laying out the circuit board. So what we're going to do is we're going to come up here to Tools and Update PCB from Schematic and hit Update PCB. And it is going to just drop all of our components here on the board, and we're just going to set them right here in the center. Now the most fun thing to do at this point is to go to View and 3D Viewer, and you can see all of the parts on the board. Now this is kind of a bad representation because it looks like there's 4 WeMos boards, but really there's only 1 and 3 shields. But either way, we get a representation of what all these parts look like. So you can see your resistor and your LED and your button and all that kind of stuff. There's not 3D models for every single part, but you get the idea. So we are going to come back to this in just a minute, but first of all, we're going to close it. So the first thing we're going to be concerned about is the cost of the board. And most PCB manufacturers, including PCBWay, give you the best deal if you keep your board below 100 millimeters by 100 millimeters. So what we're going to do is we're going to come over here to Edge Cuts, which is going to define the outside of the board. And we're going to grab this rectangle tool. So as I begin drawing the rectangle, you can see, I just click and let go. You can see the size showing up. And I want to make one that is 99 millimeters by 99 millimeters, and this will kind of give us the maximum amount of area that we have to play with. I guess we can go 99.5, and that gives us the maximum amount of area that we can play with. Now the next thing I'm going to do is click on the arrow, and I'm going to right click on this board, and I'm going to hit lock. And this will stop me from dragging the board around or accidentally resizing it and making it bigger. That would be tragic because I think that I'm in the right size and I'm not. And the other thing you want to do is you want to, down here on the selection filter, make sure that you have locked items checked, and that will allow you to right click something and unlock it should you need to. Okay, so let me explain what we're looking at. We have all the components that are in your project dropped on this thing, and when you click on one, either by clicking on it or by highlighting the whole thing, you can see that it has these blue lines. Now these blue lines are not actually your electrical connections, but they are where you will need to route wires in the future. So it's important that you orient these connectors in ways that make running the wires efficient. So if I were to flip this upside down, you would see that all these wires would have to crisscross, and crisscrossing wires are bad. Not that you can't do it, but it just makes everything more complicated. So what you want to do is you want to start placing these things on your board in a relatively intelligent manner. So we're just going to start kind of working them over here, and we're going to just start getting them in a rough idea of where they're supposed to go. Now, thanks to Gadget Reboot for reminding me, this WeMos has a USB connector on the front, so I do want the actual WeMos to be down here in the lower left so that when you're running the cable, you're not running it all the way across the board. So we're going to go ahead and take care of that too while we're doing this. So we're going to drag this down here, and then we're going to drag this one down here. So as you can see, we have the real WeMos in the lower left, then you've got shield 1, shield 2, shield 3. It doesn't really matter what order these shields are in. What we're going to do next is try to get these things to be a little bit aligned with each other. So I want to make sure that vertically these two are the same height. So I'm going to highlight them, and I'm going to right click them, and I'm going to hit Align Distribute, and I want to align these on this same axis right here. And then I'm going to do the same thing here. We're going to align these two on the same horizontal axis. So Align Distribute right there. You can see it bumped that one down. Now I want to make sure that these two are on top of each other. So I'm going to right click this and align, and we're going to pick this horizontal center, and that knocked those in line. And then we're going to do this one, right click it, and that put those in line. Totally didn't know how to do this when I first started, so that's really helpful. So what we're going to do next is we are going to come over and grab these other parts and just get them a little closer so that we can deal with them. Now, as you can see here, we have the right header. So I'm going to do the same thing I did before, where I hit the R to rotate it. And you can see that does kind of crisscross it over. And I think we want it that way anyway. So we're going to put J4 at the top because that's the right one. And then we're going to put, I'm going to leave some room here. I'll show you why in a second. I'm going to rotate this one, and we're going to put J3 right down there. This could have been one header totally, but I didn't. Now the next thing we have is our headers for the left and right side of the primary WeMOS. So we're going to put a set of headers here, and we're going to put the other side here. And again, we're making sure that they are electrically in some kind of order that makes sense. And I guess now what we can do is do this, and we'll see about aligning this way. Align to vertical center. Yeah, so that just shifted them so that they're all exactly the same. And then now we've got these power ones that can go wherever. We have this resistor that I kind of have a plan for, and everything else can wait just a moment. Now, for some reason, it is kind of hard to visualize exactly what's going on here, so you can always go back to the 3D viewer and fire that up and get an idea for what your board looks like in real life. And I feel like I have plenty of space between these. I'm going to probably slide them over, use some of this space up for something, and I kind of want as much space at the top as I can get. So I'm going to close this, and I'm going to grab these, and now I'm going to hit the M key so that I can move it with just the arrow keys. And so I'm going to slide that over so that they get closer to each other, and I get some of this space back over here. And we're going to take these three things here, these three headers, and we're going to grab those and bring them over here. So we'll kind of separate those out, and we will use this alignment tool to right click, and we'll distribute them and align them. So we're going to distribute them vertically, and then we're going to right click, align, and we will center them on that axis. Yeah, thinking about it, we have a ton of space over here. Let's go ahead and grab this and put it over here. I'll rotate it so it takes up a little bit less space, and we're going to move this over here. We'll do something with it in a little bit, but that actually puts it closer to the reset pin. We're going to want to make sure, and this is really easy to not do, we're going to make sure that we are on the silkscreen layer, and then we're going to hit this text thing, and we want to type in WeMOS D1 Mini right here, and we want to put silkscreen layers places that we're going to be able to see them so that we know what goes where. So I can go ahead and copy that, and we're gonna, there's a lot of snapping going on here. We're gonna go ahead and paste that. Not perfect, but good enough for our purposes. Now we want to look at the board again, because one of the things that can distract you a little bit is that you see labels on here, and that may not be what actually shows up on the board. So when you do the 3D viewer, you kind of get an idea of what will be finally rendered. So we have shield 2, shield 3. Down here we have shield 1 and the WeMOS D1 Mini. And so you know, but we are missing labels on all of this stuff over here. We don't know what any of these things do. So I'm going to go ahead and add some silkscreen to those things so that we can see what they do. Okay, so I sort of nudged things around a little bit. Let's take another look at it in here. Again, you can spend as much time on this as you want. Just click and drag around, take a look at everything, see if it makes kind of sense. I know we've got this button hanging out over here. Maybe that button should go a little bit lower. I don't have a label on the button saying what it does. I don't have labels on these things saying what they do, so still a little bit more work to do. Let's get back to that. Now what I want to do is I want to be a little bit stupid, and I want to add some giant text up at the top. So let me do that. Alright, so I think that's ridiculous enough. So I'm going to come over here, drag my resistor and my LED over here, and we're going to get these in the right position like so. And then we'll slide the resistor down, and then we'll put the LED on top. I think honestly this font could be a little taller. We could use the extra bold, but I think that's going to give us some issues. So I'm going to make this 9 height, so it'll be a little skinnier. Yeah, a little cheesy, but I like it. Alright, so I'm not going to waste too much of your time on that kind of thing. Everything looks about like I'm expecting. Again, you make your board the way you want to make your board. The only thing is we haven't talked about the back of the board, and so what I'm going to do over here on the silk screen, I'm going to click the back one, and then when I put my text on there, you're going to see that it's all going to be in reverse. So if I go to the 3D viewer, when I rotate this around, you can see project by another maker, and it has my GitHub. But when you're actually looking at it from the PCB, it's kind of funny. You're looking at it through the back, so you see the reverse side of it. Alright, if you've made it this far, you are so close to having your first PCB done. What we're going to do is we are going to route the wiring. So that's right, we actually have to route the wiring. And the way this works is when you go over here to the wire tool and you click on something, then basically everything that is not connected to this dims out, and you can see like I can't connect to this pin because it's not supposed to, but this thing is going to try to route these wires all over the place, and that's great with the exception of the fact that wires cannot cross over other wires on the same side of the board. So the issue is that you want to do this as efficiently as possible, and I do encourage you to route a lot of these by hand and to learn this process because it is kind of fun. But we're going to do it the easy way since this is your first PCB. So I'm going to tell you to install 2 plugins. We're going to come to the plugin manager, and you're going to type in free, and you're going to get free routing, and go ahead and click that. And then the other thing you're going to want to do probably is do PCBWay, the sponsor of this video. And I'm not just saying that because the sponsor of this video, they really do make this easier. So go ahead and click that, and once you're done, hit apply pending changes, and then come on back. It'll take a minute, but come on back. So people who design a whole bunch of PCBs probably aren't going to like that I'm going to show you this, but to be honest, it's probably the better way to learn, at least on your first PCB. So we're going to click on this free routing button, and it's going to open up something on the next page that you're not going to be able to see for a second. But you can see once I hit start that this thing goes through here and automatically routes these traces for you. Now there's a lot of settings where you can choose the width of these things and how close that a track can get to one of these pads and all that kind of stuff, and you may want to mess around with that. And in fact, I'm going to link you to a video with a lot more information on that subject, but for the most part you can just let this thing go and see what happens. So there you have it, all your tracks are routed. In the event that you don't like the way that it did it, or you need to make some kind of changes, you can come in here to edit and global deletions and click tracks and vias, hit OK, and it will take them all away, and you can just do it again. So there are 2 final steps that we need to do in the board creation process. We need to fill in these extra zones around here. By doing that, we will make the board easier to manufacture. We will provide better heat sinking. We could provide better electromagnetic and interference protection, all that kind of stuff. We want to have as much copper in the board as possible. So what we're going to do is we're going to click this add filled zone, and you're going to go somewhere outside the board, and you're going to click once. Now that will give us some options, and we want to fill both the top and bottom layer of the board. Now we could just create an island and put a bunch of copper in there for the sake of having copper, and there's nothing really wrong with that. But what we're going to do is we're going to tie this into ground so that all this copper gets tied together. So once we've made that decision, we can go ahead and hit OK, and then we're going to continue doing the outline around the board. It doesn't really matter if you're neat, you can go like this, whatever. Just get outside the board and then make sure that you close your shape by double clicking. So once we do that, the last thing we need to do is to run the design rules checker, and this is going to take a look at all the connections on the board and make sure that we are not having any issues. So we're going to click that button and I'm going to run the DRC. And you will see that we have no errors, which is good. We do have 5 warnings, which we'll take a look at those in a minute. If you have any errors, you might need to get some tech support on the KiCad Discord, but for the most part, these things go pretty well. We are in the home stretch, so let's go ahead and click on warnings so that we can take a look at these, and you'll notice that if we click on a warning, it somewhat tries to center us on it. So we can see here that, yep, that is off the edge of the board. I'm just going to click on that, and we'll select that reference, and we're going to drag that inside here. Now this will get covered up when a component is on the board there, but who cares? Let's do the next one, J3. Yep, same issue there. So we're going to grab these and get them on the board. Don't want our silk screen to be all over the floor. So we got that there. One last move there, that takes care of those two. We'll run the design checker again, and we're down to 3. So let's take a look here. We have a clipped by solder mask. Oh yeah, they're all right in that area. So we've got 1, 2, 3 with the silk screen overlap. Now this first one here, I can see an R1. That accidentally got drug into the wrong place. So we're gonna move that down there, and we'll run that DRC one more time and see that right now we have none. Yeah, okay, so this one was overlapping a couple other ones, and that was giving us all 3 of our errors. So we are done. So I'm going to show you both the manual way and the automated way to deal with the Gerber files, which are what you're trying to get out of all this stuff so that you can have it manufactured at a PCB manufacturer like PCBWay. So what we're going to do is we're going to save our project, and we're going to hit this thing that looks like a printer but different. It's a plotter. We're going to click on that, and we are going to come up here to our path. And what I like to do on something like this is I like to make my own folder in here. We're going to call this KiCad 8 Video Gerbers. And once we create that, then we're going to go ahead and double click on it to enter it and select it. And we're going to say yes, that we want to use it relative, which is a little weird terminology, but that's how it goes. So now what we're going to do is we're going to generate our drill files and generate drill files and hit close. And then we're going to plot. And we have Gerber files. You can close. So as you can see in the folder, I have a whole bunch of files, my drill files and Gerber files, and all you need to do is right click that and zip it up, and we're going to have a set of Gerber files that we can send to a PCB manufacturer. My PCB manufacturer of choice is PCBWay, not only because they sponsor the channel, but because I'm a customer on my own. As you can see, I've got 4 items in the cart right now. So what we're going to do is we're going to go to PCB Instant Quote, and we're going to quick order PCB, and then we're going to add our Gerber file and hit open. Now as you can see here, 5 boards is $5, but if you come over here to this and you click it, you'll actually be able to get 10 boards for $5 because we kept it under 100 millimeters. And so now if you have multiple items, you can combine shipping, and if you want to pay even a little bit less and you're not in a hurry, you can come out down here to global standard shipping and get it for, you know, almost 1/3 of the price for shipping. So anyway, once you're done, you have it the way you want it. You can choose board color if you want red boards, if you want a different color solder mask, whatever you want, and then you hit save to cart. Make sure that you don't have anything illegal in there and save it. If you think that's too complicated, you can come over here to the plugin and content manager on the main KiCad screen, search for PCBW, and install the PCBWay KiCad plugin. And all you have to do is come up here and click the PCBWay button, and that will pretty much take you straight there. It brings up the website with your Gerbers already loaded. You can just choose your quantity and you are off to the races. So this is not a commercial. One of my absolute favorite parts of PCBWay is their shared projects. Not only getting them from other people, but I love actually putting my own on there. And you get really good commission that you can use to buy PCBs. So basically, all of your PCBs can be free if you wind up putting your projects up here on their shared project. There is a Create Project button in the upper right hand corner, and all you need to do is fill out a title, give it a couple of categories and a basic pitch, and then we'll move on. So I gave it a title, the WeMOS D1 Maxi Prototyping Shield, and gave it a couple of categories, have my elevator pitch. So from there, I just need to upload my Gerber files, and I'm gonna put a picture in here. I'll get some more pictures once I get the boards in my hand. And then one of the cool things is that you can put the bill of materials down here and you can actually use your own affiliate links. So if you're part of an eBay or Amazon or AliExpress affiliate link thing, people who even just look at the board can use your links to buy stuff, and you can get credit for that as well. So you can do something like this where you say, explain what the board does, you give your affiliate links, and then you say it's an Arduino ESP8266 hardware, give it some keyword things, and then hit submit, and your project will be online. So I want to thank you guys for sticking with me through the video. I want to thank PCBWay for sponsoring the video. I want to thank KiCad for the awesome software. I will have some links to some great resources for learning and getting support on KiCad. I am not able to offer support for KiCad in the comments of this video, but I do hope that you learn a lot and that this begins a lifetime journey of PCB design. So hey, thanks for watching and have a great day.